We will begin by dividing radicals. Dividing radicals is actually known as, aka, rationalizing the denominator. Rationalizing the denominator. You cannot have a radical in the denominator. So to do this, we will just multiply by the radical or some number that will make the radical perfect. Let's begin. So we will work on some examples. So 15 square root 6, we cannot have square root 6. So when we think of 6, what can we multiply it by to get a perfect number? Well, we can multiply by radical 6. Whatever you do downstairs, you have to do upstairs. And a lot of students just replicate what the denominator is, and that's fine. You just might have to reduce a lot more. So in the numerator, we have 15 square root 6. Just squish them together, because 15 is outside, 6 is inside. Square root 6 times square root 6, that's just going to leave us 56. You have to reduce. Now, the square root 6 and 6 cannot reduce because we have a radical, or that 6 is inside and the 6 is on the outside. Now if you look, 15 over 6, that is a reducible fraction. If you reduce it by 3, you can get 5 square root 6 over 2. Now you don't divide the radical by 3, only the coefficient. 12 square root 8. Now, one thing we can do is say, okay, what number can 8 go into, or what can we multiply by 8 to get to a perfect number? You can definitely just multiply by radical 8. Or if you think, hey, 16, 8 can go into 16, well, I just need to multiply by square root 2. Well, if you multiply the denominator by square root 2, you have to multiply square root 2 upstairs as well. So square root 8 times square root 2, that's square root 16. That will give you 4. 4 goes into 12 3 times, so 3 square root 2. You could have also done the same thing, which I've seen a lot, and it is not wrong. Students just say, hey, I'm going to multiply by square root 8. I don't want to have to think extra. I'm just going to multiply by what we have here. Well, that's fine, but you have to reduce even more so. So first of all, we have that square root 8, which we can reduce. That's 2 square root 2, which will give us 24 square root 2. Square root of 8 is the same thing as 2 square root 2. 2 times 12 is 24. And then we have square root 2. 8 goes into 24 3 times. Therefore, we get our 3 square root 2. So, by going a simpler way, I guess you can say this is the simple way, you can get to your answer quicker. Or if you just want to say, oh, multiply by square root of 8, you can do that, but be cautious that you will have to simplify a lot more. Square root 7 over square root 3. So we will multiply by square root 3. 9 is the next, or the perfect square we can get to. 7 times 3 is 21, so square root of 21 divided by 3, and we are finished. Do not take 3 into 21, because we have an outside 3 and an inside 21. We just can't do that. We have square root of 8 over square root of 2. Well, before we go on and multiply by square root 2, you can see, hey, looky here. Square root of 8 and square root of 2. 2 can go into 8. So we can actually rewrite this as square root of 8 over 2. 8 divided by 2 is 4. And we have 2 remaining. If you did not see that and you went ahead and said, hey, I'm going to just multiply by square root of 2. Well, you have 2 downstairs and you have a big 16 upstairs. Well, square root of 16 is 4. You divide by 2 and you get the same answer as 2. This is why I love math so much. There are so many ways you can get to the same answer as long as you are performing the correct rules in math. So 2 square root 10. So we can multiply by square root 10. So 2 square root 10. Square root 10 times square root 10 is just plain old 10. 2 goes into 10 5 times, so 4 2/10 is 1/5, and we have a square root 10 upstairs. Do not simplify any further. That 10 is inside, the 5 is outside. Now, that was the easy part. Now we're going to work with the denominator with 2 terms in the denominator. So what we're going to do is use the conjugate. So we are going to use the conjugate to eliminate the radicals. Now, you're probably thinking, what in the world is a conjugate? A conjugate is you keep the terms the same, whether they're positive or negative, but instead of a plus sign, which we will look at this as a plus sign, we will write a negative, or if we had a negative, we have a positive. So either way, we will have the opposite operation on these. And if you know your perfect, or your your difference of 2 squares, you'll see that it will be square root of a squared minus square root of b squared. Therefore, you'll have a minus b. Okay? Now, I know that sounds confusing at first, but let's look at some examples and really go through the FOIL method for our denominators so that you can see how the radicals disappear by using the conjugate. And essentially our middle term cancels out, leaving us without a radical. So 7 over 5 plus square root 3. Well, we have a radical in the denominator, we have an addition, so we have to multiply by the conjugate. So 5 minus negative 3. Well, whatever you do downstairs, you have to do upstairs. The numerator, I'm going to keep it as 7 times 5 minus square root 3. That's legal to do. That's actually factored. If you want to multiply that 7 through, that's okay too, but factored form looks a lot better. Now, we can't keep this as a factored form, unfortunately. So let's do the FOIL method. 5 times 5 is 25. Minus 5 square root 3 plus 5 square root 3 minus square root of 9. Or you can see that square root 3 times square root 3, that's just going to give us a 3. If you notice, our middle terms are opposite of each other, so they cancel out. So we have 7 times 5 square root of 3 upstairs. Down here, since our middle terms cancel out, we're left with 25 minus square root of 9 is 3. So essentially, all we have to do is take 5 times 5, which is 25, and then square root of 3 times square root of 3, which is 3. Subtract those, and we will get our value. So instead of going through the FOIL process every single time, we can shortcut it and do our firsts and our lasts. So 8 over 3 square root 2 minus 4. So we have to multiply by the conjugate, so keep the 3 square root 2 and the 4, but we're going to add the 4 instead of subtract. Again, we're going to keep the numerator factored. A lot of times that's a lot better to keep it factored, just in case if this 8 can the 8 can be reduced with the denominator. Now for this next part, we'll just do the shortcut. So we need the first, so 3 times 3 is 9 times square root 2 times square root 2, that's just 2. And then we have 4 times 4 is 16. We're going to subtract that. So we still have our numerator, and our denominator is 18 minus 16, which is 2. 2 goes into 8 4 times, and then we can leave our answer in the factored form, or you can distribute that 4 through. Does not matter. I prefer, as an instructor and as a mathematician, to see and leave my answers in factored form. 5 over negative 2 plus square root 3. If you have a negative value, it has to stay negative. If your first value is negative, it has to stay negative in order for this to work. The only thing that changes is this addition sign, or it could have been a subtraction sign. Either way, it has to, that operation has to change. Don't change the negative 2 into a positive 2, otherwise you are not you're not working it correctly. So 5 times negative 2 minus square root 3, and again negative 2 times negative 2 is 4, minus 3, square root 3 times square root 3 is 3. So you have 5 negative 2 minus square root 3 over 1. You can leave your answer like this, or a negative 1 can factor out, so we can have a negative 5 times 2 plus square root 3, which is preferable, or you could have just multiplied that 5 through, and it would still be correct. Again, it depends on what your instructions say, or what your personal instructor is looking for or wants as an answer. This concludes this video.